This is Ms. DB. In this video, we are going to go over slope-intercept form of a line. This should be a review from Algebra 1 for you, but we'll review and make sure you remember it all. So when we have a linear function, that is a line, there's lots of different ways to write it, and one of the ways is called slope-intercept form. If we write it in slope-intercept form, it's y equals mx plus b. M is the slope, and b is the y-intercept. So if, for example, y equals 3x minus 5, the slope would be 3, the y-intercept would be negative 5. So all you have to do in these first problems is figure out what is the slope and what is the y-intercept for these equations. Letter C might be a little bit tricky. It just says y equals x. But I wrote how you could rewrite it, and then you can identify the slope and the y-intercept. So sometimes the y-intercept is 0. D is also a little bit different. It says y equals 3.75. We could rewrite it as y equals 0x because there is no x, so that must mean it must be 0x. And then it says plus 3.75. I could graph that using technology. I'm just going to graph it by hand though, so I don't have to switch to another program here. Y equals 3.75 would be 1, 2, 3, here's 4. It would be right about here on the y-axis. Y equals 3.75 is a horizontal line that goes through y equals 3.75. So that is the line. So the slope of that line is a particular thing. The y-intercept is 3.75, but the slope is 0. It turns out that all horizontal lines have a slope of 0. E is 1/2 x, and it doesn't say what the y-intercept is, so look back at C for a hint on that one. And then F, what would the slope of a vertical line be? Would it have a y-intercept? So vertical lines, let's get a different color here, look like that. And in the next section here on this worksheet, we're going to talk about slope as being rise over run. Well, if you pick 2 points on a vertical line, you can find the rise between those points. I could say, well, these are going, it looks like it's only about distance of 2 between them for a rise. But the run, they don't go left or right. There is no run. And 2 over 0 is undefined. We can't have division by 0. We can't have 0 in the denominator when we talk about slope. So the slope is undefined in a vertical line. Look at it again to see if it would have a y-intercept. This red line here is never going to touch my y-axis, which is over here. So it does not have a y-intercept. So the slope is undefined for all vertical lines, it turns out. All right, here's, like I said, we're going to talk more about slope as being rise over run, or the change in y over the change in x. Rise over run slope. And again, we often use m for our variable for slope. So you might see that in the following problems. We can also use the slope formula, which is given here. This is the slope formula. So there's more than one way to find slope. Usually, if I'm given a graph, I use this method, where I find the change in y over the change in x, and I write it like a fraction. If I'm just given points, I usually would use the slope formula. But some people like to always use the slope formula, and some people always like to graph them and then look at the change in y over the change in x. So to use the slope rise over run on a graph, you pick 2 nice points on your line. Now, I'm going to look at graph B. In graph B, I certainly see that this looks like a good, nice point. And when I say a nice point, I mean one that goes right through the crosshairs of that coordinate system. Like, I would not pick this point because I don't know exactly what the x value is, because it's a fractional number in between 4 and 5, or 3 and 4. But look at this point right here. That looks like it's going right through the corners of the grid, so I'm going to pick that point. The next thing that you want to do is you want to make a right triangle. It doesn't matter if you make your right triangle below the line or above the line, whichever you prefer. I'll go below the line so I can kind of follow the y-axis on this one, and then I'll go straight across. So you pick one of your points and you go up or down until you reach the same height as the other one, and then you go straight across. Now I have to do rise over run. So from this point, I would go down 1, 2, 3. I went down 3, so I'm going to say -3. Then I go 1, 2, right. That's a +2. So my rise is -3 and my run is 2. What if I had instead, where's my eraser? What if I instead had drawn my triangle above? Would that change my slope? Let's check. So I'm going to draw my triangle from, I'm going to use the same 2 points because I like those points. So this time I'm going to make my triangle, my right triangle, over and from there to there. So when I do the rise, I'm going to start at this point and I'm going to go 1, 2, 3, up. And then I'm going to go 1, 2, over. Well, I went to the left, so that would be a -2. So when I do it the other way, I get a slope of 3 over -2. These are equivalent fractions. Whether the negative is on the top or the bottom, it's the same fraction, and you could just write the negative in front if you wanted. So those are all equivalent fractions. You don't have to worry about which way you're doing it. The most important thing is that your slope in B is negative, and that's because it's going downhill when you look at it from left to right. Downhill slopes will be negative, uphill slopes will be positive, and we already talked about horizontal and vertical lines, what their slopes will look like. So here's some more lines to practice on. E, in case you have a hard time seeing it on your worksheet, it's a horizontal line right there. I don't have any vertical lines on here, but that's line E is that horizontal line right there. So just write the slopes. Oh, you're going to find the y-intercepts too. The y-intercept is just where it crosses the y-axis, that's all. So in A, you have to estimate because the y-intercept is not 1 or 2, it's in between there. It looks like, to me, it's about, I don't know, 1.3. So that's B is the y-intercept and M is the slope. And remember, for slope, you can pick any 2 points on the line that look good to you, like nice integer coordinates. So for A, I would pick that point, and I mean, I could go all the way over here if I wanted. That looks like a good point. And I could make a nice big triangle. There's probably a smaller triangle to use, but that doesn't matter. And then the rise, remember you count 1, 2, 3, 4, 5, 6. I went down 6, and then I'm going to go to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9. So -6/9. Now that slope could have been simplified, so let's do that over here where I have a little more room. I could divide each of these by 3 to simplify this fraction. -6 divided by 3 is -2. 9 divided by 3 is 3. So this would equal -2/3. So that would be the simplest, best way to write your slope. And note that when I'm counting my slope, I'm counting the spaces. I'm not counting, I don't start here and count every point, 1, 2, 3. Then you'll get the wrong answer. You count the spaces of your height of your triangle. All right, so then the next section, you are graphing by using slope and y-intercept. So these, you can either graph them like in Desmos or Sketchpad or something, or I have some charts down here that you can graph them on. So when you graph a line, let's look at this example. If they give you the slope and the y-intercept, the first thing you do, step 1, is to put the y-intercept on your graph. So over here, the first step they did was they put the y-intercept on at 4. Goes right on the y-axis. And then the second step is to apply the slope to that point. So you're going to start at that point and then do the slope. So this one, it says the slope is -2. That's only one number, but you can always put a number over 1 to get the run. So my slope is -2 over 1. So that is a rise of -2, which means 2 units down, and then I go 1 unit right. So from that point, I go 1, 2 down, and then 1 more to the right. I put another point, and then you draw a line through the points. That's step 3. So let's look at B, because B, the slope is given as a decimal. 0.2 is equal to 2/10, because that's what decimal 0.2 means, and that's the same as 1/5. So the first thing I'm going to do for B is change that to a fraction, because it's much easier to graph if it's in fraction form. So that means that y is equal to negative 1/5 x plus 7. That's what I'm going to graph on the coordinate system down here. So I start by putting a point on the y-intercept, that is 7. So right there. Then from that point I apply the slope. The slope is negative 1/5, so I'm going to go down 1 and to the right 5. Now note that this is 1, this is 2, this is 3, this is 4, this is 5. So these are every 2 units, the grid system. So 1, 2, 3, 4, 5, about right there. So that's my second point. Then I would use a straight line tool, and in fact I'm going to get that from the insert. I'll show you that. Insert, and then under illustrations, if it's small, I need my shapes. And I'm going to get the line tool. And I'm going to connect those 2 points. But I don't want to just connect those little points like that. That's way too short. I need to go through the points. So I'm going to make this longer on both sides. You don't want to just make a little tiny line between your 2 points. You want it to go all the way through. And even if you had arrows on the end, that'd be even better, but I didn't pick the right one that had arrows, and I'm not going to worry about that. So there is the line that would go through those points, and that is the line y is equal to negative 1/5 x plus 7. So I have to label this. I'll just write that this was for B, problem B, so that when I'm grading it, I can find which lines go with which. Because you're going to have to put 2 or 3 lines on each graph if you're doing it by hand. If you're doing it in Sketchpad, you could probably pretty easily just make a new one for each one. Or you could put, again, 2 or 3 on each graph is fine. I can still read them that way. Don't put them all on one graph, though. It gets too hard to read. Okay, next you're going to decide which ones are parallel. So after you graph all 5 of them, then look and see which ones are parallel. Parallel lines never intersect. They never intersect. So they're like train tracks. They're always the same distance apart. They will never touch each other. They have the same something, and you're going to find out what that is. You can read about it too if you don't remember. It's in our textbook. And then you're going to decide when you're done what kind of slope parallel lines have. And now the last section here, we're going to be writing equations of lines. So here's an example. We start by writing the slope-intercept form of a line, y equals mx plus b. If you are given the slope and the y-intercept, all you do is plug them in and you're done. If you're only given the slope and a point on the line, this is not the y-intercept. Not b. You have to find b. So you start by replacing m with the slope that they give us. Then you use the point they give us and replace the point x and y. So we are going to replace y with 1, and we're going to replace x with 3, because that's the point they give us. Then we just simplify and solve this to find b. We didn't know what b was, so that is our variable. And we simplify this and find b. And then don't forget the last step, which is now to write the equation, now that you know what b is and you were already given what m is, and you just replace them like you do in the easier ones. So you are going to do one like that for 8. Now 9's a little different. It says the line is parallel to the line y equals 2x plus 9. It doesn't tell us what the slope is. However, if the lines are parallel, we know the slopes are equal. So I just gave you an answer for another question. So the slope will be the same as in the given line. So in number 9, they give us a line, and we can find the slope of that line because we know that it's y equals mx plus b. So we know that the slope is 2. We don't use the 9 for anything. We just needed that equation for the slope. we also have a point on the line. So that's x, y is equal to 0, 5. So x is 0, y is 5. So when I write y equals mx plus b, we can replace m with 2. We don't know b, but we are given a point on the line. So now I can replace y with 5 from the point, from right here. This means 2 times x, x is 0. And when we simplify this, we get 2 times 0 is 0, plus b, we get that 5 is b. So it turns out they really did give us the y-intercept in this case, because the y-intercept is when x is equal to 0. And then you're ready to write your equation of your line. When you do number 10, you'll have to do another step or two to find b. All right, so good luck with this. Let me know if you have any questions, and have a great day.